everybody. This is Nageshwar Rao, and now here I am going to present you and my project, which is OMR analyzation full stack project, which uses and fast, smart, and error-free OMR evaluation. So let's check the problem statement for now. Time consuming. Actually, the main problem is mainly whenever you are checking the OMRs manually, you have to individually tick and correct whether the OMR sheet is correct or wrong, whether the answer is correct or wrong. And at the same time, here we don't have any visual data or any visually representing names in the OMR sheet, which leads to an error of correcting another answer to it, and also which is mainly error prone. Human evaluation leads to major errors and costly operation, which is takes a time consuming for everyone to evaluate the OMR sheets. So they'll be paying more if it's take more time for each person. Our solution. So now the solution which we are going to give is answer input. Basically what we are going to do is we are going to give an answer input which is in the form of JPG, PNG or JPG. Later that inputted images are being uploaded to the OMR sheet uploader that we are going to be using. After that, the backend server which we are going to be basically using the Python, uses the OpenCV which automatically evaluates the bubbles which are being bubbled by the black pen or the blue pen specifically, automatically locates them and then stores them into a local storage using some of its list or dictionaries. So here is the workflow. First of all, we upload the answer key to the our backend server, which basically compares the OMR answers and the actual answers to give a grading. And next we will upload the answer sheet folder. If in the case to upload each file to the program, it takes a lot of time. So what we have done is to classify each and every answer sheet into a single folder and then upload a whole folder to it, which the Python script itself generates its own separate images. Then backend processing, using the OpenCV and Python algorithms, it analyzes the bubble patterns and the precision and forms an evaluated list in stores it. Evaluation intelligent matching system compares the detected bubbles and answer key to evaluate, and result generation. Lastly, we will be giving the results in the result generation. And next, tech stack. Though basically we are going to use some of the technologies. For front end, we are going to use a modern architect like HTML5, CSS, and JavaScript, not majorly as Node.js. And as per the data and development, so the MySQL and the MongoDB databases were meant to be used, since it's just a small scale and not a storage type of. We have stopped using it, and we are using the structured data storage like list and dictionaries, and scalable architecture design which enables you store the multiple answer sheets. Processing logic. For processing the logic, we are going to use the Python Flask Django. Basically we are going to use the Flask. OpenCV which is an image processing, basically known as Open Computer Vision, and NumPy for the numerical computations. So an infrastructure, local server compatibility, and cloud development ready. So basically what we are going to do is to develop an local server itself, not and in the future scope we will be developing to the cloud services, which helps a lot of persons to use, not only a single person at a time. Benefits and impact: fast and accurate. So almost we are going to give an accurate and fast results compared to the normal manual evaluation. User friendly. So simply it has an simple elements: login page, sign up page, and a page where we can upload the answer sheet, basically your original answers key, and then the OMR sheets, and the structured storage like list helps to store the results temporarily. Next, highly scalable. I mean, in the future, if there is more user data, then we can store. Okay, now let's see the program that we have done. So this is basically the whole backend that we are going to be using. So here if you see, here is the CV2, which is computer vision version 2, or basically we can say, which this import module we are going to be using for the image processing, basically to find the bubble, whether the given sheets has bubbles, or if they have bubbled with a black or blue pen, then it will be highlighted in the white color using the grayscale. That leads us to identify the where the bubble is colored, and to get the answer, particular answer. So numpy, here comes the numpy to identify the where the bubble is identified using the matrices, image matrices. And pandas, so basically pandas is used to I mean used for data that we are going to be giving, data that we are going to be given. Basically the answer key that we are going to be used, we are going to give in a CSV file or Excel file, and here using the OS. So to upload the files that we are going to give for the backend, so we are going to use OS for that sake. Flask, which is basically you all know used for server connections like HTML to the R server connections. This sends request and renders the templates that we are going to use. So basically these are the templates that we will be using in this project. And so next, talking about this app, so we will be starting the server using the Flask, assigning it to the variable app, then uploading the folders, static folder, debug the folder. There are basically two upload folder uploads. So static folder, here you can see here is the static folder, basically holds the debugged, what we say, which means the images that we gave it, basically it converts into the grayscale and other quant train scales, and that grayscale images are being stored in the static debug folder. And OS make DRs, so we are going to use these DRs. So basically upload folder holds the images that we are going to be using. Here you can see key sets, here are the demo images that we have uploaded until now, and here is the debug sets here until now, what we have done for the testing stages. And next, subject mapping. Wait a moment. Subject mapping, here list range 20, EDA range 20. Basically what it does is gives an SQL prompt from each Power BI. So basically what it does is it enlists the questions for specific subject: Python, EDA, SQL, Power BI, and statistics, which the key is provided for us, which has these subjects. And total questions we have 100, and total options we have only 4. And here is the option mapping: A0, B1, and C2, and D3. So this is the bubble darkness threshold. Basically this says how much the bubble is darkened. So we have set it to 115, and in future if the bubble is less darkened, so we will be decreasing to less dark. And then here is the load key for CSV file. So basically this function, what does this function is, it loads the CSV file which has a key for every OMR sheets, basically the answers, correct answers for it, and loads it and assigns to it into a dictionary. You can see here is the answer key dictionary, and then after that we are going to be comparing to that 4-point transfer image points. So basically this whole function gonna help us to identify the where the answer is present using the numpys. And this is the shortcuts. Basically this does is create an contours of an image, and this is our main CV function, which basically processes our sheets. So this processes, here you can see the previously we have found the counters we are going to be given to this for thresholding, which basically identifies the darkness and gives it in a grayscale. And uh, here is the score, which means this whole this whole thing does is compares the score to the original keys and the normal keys. And here you can see a app routes. This routes basically does is to connect between the HTML connections and the server, and handles the data communication pipeline between the HTML connections and the server side. And then this is our main function. Templates. So here is the templates. So this is our dashboard HTML. Here we have been using Cloudflare CSS and Google Maps Bootstrap, and this is the whole CSS. So we are in a little bit of time we will let us see the how the CSS function works. Okay, so this is our home, which basically modifies. Let's open our CSS file. So here is it, the server has started. So let's check this out. So basically first we will be having a home page where nothing is there, just an home analyzer, that's it. And next, when we click on start now or their login pages, you will be going to login something and a password. If you enter that, you will be logged into your account, in which you can see this is an account John Smith. And here if you see, you will be having total evaluated students and total OMR sheets uploaded, and average score for this whole OMR sheets, not the total students that we are going to be using. And here basically what goes is the CSV files being uploaded here, which is basically our answer key. And here if we see, here we can upload the whole folder. So let's upload them. Where yes, here is it is. And then let's upload this, and if we click that, and let's go and use this set upload. Yes, upload. After uploading, you will be getting the results for that. So basically now the images consist of nothing has been bubbled. So here we are getting the found only 0 bubble out of 400. So basically here we uploaded on almost of 20 and 8 images, in which basically has a many bubbles to be identified. And what it does is, currently it has 0 bubbled. So as per talking our results, as per talking of this is our final product. And I'll be giving you my github repo. Wait a moment, I'll be logging it now. GitHub. And here I have uploaded my whole project in the GitHub, and I'll be posting with you this I'll be posting you this later. Yes, I'll be adding a readme in future right now. Thank you.